Next heavy metal that we are going to tackle is lead. Lead is a naturally occurring toxic metal found in the Earth's crust. Its widespread use has resulted in extensive environmental contamination, human exposure, and significant public health problems in many parts of the world. Knowing that, let's now proceed to the sources. Number one is lead-based paint. Lead-based paint and lead-contaminated dust are the most common sources of lead poisoning. Paint containing lead was not banned in the United States until 1978. So the homes that are made before this time had a good chance of having lead-based paint which can chip, peel, or flakes. Household dust can contain lead particle released from old paint during remodeling by sanding, scraping, and tearing into painted surfaces. Painted areas where friction occurs, such as the doors, windows, and drawers, can also contain lead-contaminated dust. Watch out for toys and jewelries too. Some toys and toy jewelry contain level of lead that may have a serious health risk to children. Parents should check with the Consumer Product Safety Commission to see if their child's toys and jewelry are recalled. Although antique and salvage items and metals may not appear on the recall list, they may contain lead, especially items that are painted. So what is product recall? It is a request from a manufacturer to return a product after the discovery of safety issue or product defect that might endanger the consumer or put the maker, seller at risk of legal action. Anyway, a country's consumer protection law will have specific requirements in regards to their product recalls. In manufacturing and recycling activities like soldering, we can see them in pots made of recycled scrap metals. Drinking water delivered through lead pipes or pipes joined with lead solder may also contain lead. Here, workers are really exposed, but they are being trained what are the do and don'ts before they are dispatched to a certain job. This is to avoid uncertain incident of toxicity. Traditional home remedies and cosmetics. Some remedies may contain up to 100% lead and are very dangerous. Home remedies that may contain lead are arzeton ingrata, both fine orange powder, may be used in the Hispanic community for indigestion or upset stomach. Peiloa, a red-orange powder, may be given to children in Vietnamese and Hmong community as a cure for rash and fever. Gazard, Baligoli, and Kandu may be used for stomach ache in some Asian Indian community. These are nice to know, but hopefully, with the knowledge and technology, this will not be used anymore because of its danger to health. Certain cosmetics, especially those from Middle East, India, and Asia, may also contain high level of lead. So for us ladies, be cautious to know the content of our cosmetics before you apply it to yourself. Lead glazed ceramic ware, pottery, and leaded crystal. Are you familiar with these things in your house or can you see them in your house? Lead can be used to make ceramic glazes with deep and brilliant color. Imported old, handmade, or poorly glazed ceramic dishes and pottery are especially at risk of having lead in the glaze. So lead may also be found in leaded crystal, powder, and brass dishware. So how can we get this into our body? The acid foods or drinks such as orange, tomato, and other fruit juices, tomato sauce, wines, and vinegars may cause the lead to draw out of the glaze and contaminate the food or drink with lead. See, parents may unknowingly bring lead home on their hands, clothing, and shoes. Jobs that expose people to lead include painting, construction and home remodeling, radiator repair, battery or scrap metal recycling, pottery manufacturing, working with guns and ammunition, industries using lead solder, roadwork, and shipbuilding. Precautions are always implemented to all employees in an industry or big industry, but the problem is for the workers in a small manufacturing wherein some rules and regulations with regards to toxicity are not implemented. This is because lack of regulatory body to examine the area. Dust and fumes from hobbies can also be a source of lead. Hobbies like stained glass windows with lead solder, glazing and firing ceramics, making and handling ammunition, fishing weights, target practice, finishing furniture, remodeling old homes, and jewelry making. Route and entry and exposure. Number one, ingestion. Ingestion of lead-contaminated dust, water from leaded pipes, and food from leaded glaze or lead-soldered containers. Number two, inhalation. Inhalation of lead particles generated by burning material containing lead, for example, during smelting, recycling, stripping, leaded paint, and using leaded gasoline or leaded aviation fuel. We also have dermal and endogenous, and an additional source of exposure is the use of certain type of unregulated cosmetics and medicine. Initially, lead poisoning can be hard to detect. Even people who seems to be healthy can have high level of lead in the blood. Signs and symptoms usually don't appear until dangerous amount have accumulated. Let's say for example in adults, the normal value is less than 10 micrograms per deciliter or 0.48 micromoles per liter of lead in the blood. Currently, the CDC blood level of concern is 5 micrograms per deciliter of lead in the blood of children. But these new recommendations do not change the treatment, which is chelation therapy, to be considered when the blood test result is greater than or equal to 45 microgram per deciliter either in children or adult. Babies exposed to lead before birth might be born premature, have low birth weight, and have slow growth. Young children are particularly vulnerable to lead poisoning because they absorb 4 to 5 times as much ingested lead as adults from a given source. Exposure to lead can seriously harm a child's health. It can cause damage to the brain and nervous system, learning and behavior problems, slow growth and development, and hearing and speech problems. This can also cause lower IQ, decreased ability to pay attention, and underperformance in school in the long run. Now, let us run down the lead poisoning symptoms in children. We have developmental delay, learning difficulties, irritability, loss of appetite, weight loss, sluggish and fatigue, episodes of abdominal pain, vomiting, constipation. There will be hearing loss, seizures, and eating things that are not food, and this psychological disorder called pica. Although children are primarily at risk, lead poisoning is also dangerous for adults. Signs and symptoms in adults might include high blood pressure, joint and muscle pain, difficulty in concentration, headache, abdominal pain, mood disorders, reduced sperm count or abnormal sperm count, miscarriage, stillbirth, or premature birth in pregnant women. Environmental effects of lead. Not only leaded gasoline causes lead concentration in the environment to rise. Fuel combustion, industrial processes, and solid waste combustions also contribute. Lead can end up in water and soils through corrosion of leaded pipelines in a water transporting system and through corrosions of leaded paints. Health effects of shellfish can take place even when only very small concentrations of lead are present. Soil functions are distributed by lead intervention, especially near highways and farmlands where extreme concentrations may be present. Lead is particularly dangerous chemical as it can accumulate in individual organisms but also in entire food chains. To summarize, here are some key facts. Lead is a cumulative toxicant that affects multiple body systems and is particularly harmful to young children. Lead in the body is distributed to the brain, liver, kidney, and bones. It is stored in the teeth and bones where it accumulates over time. Human exposure is usually assessed through the measurement of lead in blood. Lead in the bone is released into blood during pregnancy and becomes a source of exposure to the developing fetus. Lead exposure is preventable. Now, let's proceed to the third heavy metal, arsenic. Arsenic occurs in many minerals, usually in combination with sulfur and metals. It is a pure elemental crystal and it is a metalloid. For the sources, we have the major industrial processes like mining, metal smelting, burning of fossil fuels, arsenic-containing pesticides, and arsenic in the preservation of timber. Timber means wood or logs. Arsenic is used as an alloying agent, processing of glass, pigments, textiles, paper, metal adhesives, wood preservatives, and ammunitions. Arsenic is also used in the hide tanning process. To a limited extent, in pesticides, feed additives, and in pharmaceuticals. Another source is tobacco. We all know that a lot of chemicals are present in tobacco. Now, how is this heavy metal arsenic present in tobacco? People who smoke can also be exposed to a natural inorganic arsenic content of tobacco because this plant can take up arsenic naturally present in the soil. The potential for elevated arsenic exposure was much greater when tobacco plant used to be treated with lead arsenate insecticide. Another source is drinking water. The greatest threat to public health from arsenic originates from contaminated water. Drinking water, crops irrigated with contaminated water, and food prepared with contaminated water are all sources of exposure. In foods, we have meat, poultry, dairy products, and cereals can also be a dietary source of arsenic, although exposure from these foods is generally much lower compared to exposure through contaminated groundwater. In seafoods like fish, shellfish, arsenic is mainly found in its less toxic organic form. Health effects. Inorganic arsenic is a confirmed carcinogen and is most significant chemical contaminant in drinking water globally. Inorganic arsenic compounds, such as those found in water, are highly toxic. Arsenic can also occur in an organic form. Organic arsenic compounds, such as those found in seafoods, are less harmful to health. The immediate symptoms of acute arsenic poisoning includes vomiting, abdominal pain, diarrhea, numbness and tingling of the extremities, muscle cramping, and death in extreme cases. Long-term health effects that may be associated with long-term ingestion of inorganic arsenic includes in the skin, we have skin pigmentation changes, skin lesion and hard patches of the palms and the soles of the feet, which can either be a precursor of skin cancer. Another is cancer of the bladder and cancer of the lungs. We have developmental effects, diabetes, pulmonary diseases, cardiovascular diseases like arsenic-induced myocardial infarction. Arsenic exposure has been linked to Blackfoot disease, which is a severe disease of blood vessel leading to gangrene. It is also associated with adverse pregnancy outcomes and infant mortality with impact on child health. Exposure in utero in early childhood has been linked to increase in mortality in young adults due to multiple cancers like lung and heart attacks and kidney failures too. Despite of the developmental effect, numerous studies have demonstrated negative impacts of arsenic exposure on cognitive development, intelligence, and memory. Prevention and control. The most important action in affected communities is the prevention of further exposure to arsenic by the provision of safe water supply for drinking, food preparation, and irrigation of food crops. There are a number of options to reduce levels of arsenic in drinking water. Number one, substitute high arsenic sources such as groundwater with low arsenic microbiologically safe sources such as rainwater and treated surface water. Number two, discriminate between high arsenic and low arsenic sources. An example for this is test water of arsenic level and paint tube wells or hand pump different colors. This can be effective and low cost means to rapidly reduce exposure to arsenic when accompanied by effective education. Number three, blend low arsenic water with higher arsenic water to achieve an acceptable arsenic concentration level. Number four, install arsenic removal system. Technologies for arsenic removal includes oxidation, coagulation precipitation, absorption, ion exchange, and membrane techniques. Number five, long-term actions are also required to reduce occupational exposure from industrial processes. Number six, education and community engagement are key factors for ensuring successful interventions. And number seven, high-risk populations should also be monitored for early signs of arsenic poisoning, usually skin problems. After learning about the three most common heavy metals, let us now proceed to radon. What is radon? Radon is a naturally occurring radioactive gas. It is produced when uranium, thorium, and radium break down in soil, rock, and water. Radon is odorless, tasteless, and invisible. It can accumulate in some places where ventilation is inadequate, such as in an underground mine. Half of a given quantity of this break down every 4 days. When radon undergoes radioactive decay, it emits ionizing radiation in the form of alpha particles. Radon tends to enter buildings at their lowest point. It often makes its way in through splits in foundations, cracks in walls, gaps around pipes, cavities inside walls, and water supply. The gas is likely to build up in a poorly ventilated, airtight buildings. This illustration shows how radon enters a building by fractured bedrock, soil, well water, loose fittings, groundwater, rocks, drains, sumps, and windows. Radon occurs throughout most environments in very small quantities. Everyone breathes in radon every day, usually at very low levels. It becomes dangerous if a person is inhaling it at high levels for a long time. Radon accounts for the majority of most people's exposure to ionizing radiation. Now, what is ionizing radiation? It is a type of energy released by atoms that travels in a form of electromagnetic waves. The spontaneous disintegration of atoms is called radioactivity, and the excess energy emitted is a form of ionizing radiation. There are three main kinds of ionizing radiation. Number one, alpha particles. Number two, beta particles. Number three, gamma rays and X-rays. People are exposed to natural radiation sources as well as human-made sources on a daily basis. Natural radiation comes from many sources, including more than 60 naturally occurring radioactive materials found in soil, water, and air. Radon is the main source of natural radiation. People are also exposed to natural radiation from cosmic rays, particularly at high altitude. Human exposed to radiation also comes from human-made sources ranging from nuclear power generation to medical uses of radiation for diagnosis and treatment. Exposure to ionizing radiation can either be internal exposure or external exposure. When it is internal exposure to ionizing radiation, it occurs when a radionuclide is inhaled, ingested, or otherwise enter the bloodstream. For example, it is via injection or through wound. Internal exposure stops when radionuclide is eliminated from the body, either spontaneously via excreta or as a result of a treatment. External exposure may occur when airborne radioactive materials such as dust, liquid, or aerosols are deposited on the skin or clothes. This type of radioactive material can often be removed from the body by simply washing. Exposure to ionizing radiation can also result from irradiation from an external source, such as medical radiation exposure from X-rays. People can be exposed to ionizing radiation under different circumstances at home or in public, at work, or in medical setting as a patient, caregiver, or a volunteer. Exposure to ionizing radiation can be classified into three exposure situations. It can either be planned exposure situation, existing exposure, or emergency exposure situations. In planned exposure situations, result from the deliberate introduction and operation of radiation sources with the specific purposes. If it is existing exposure, is where exposure to radiation already exists and a decision to control must be taken. For example, exposure to radon in homes or workplace or exposure to natural background radiations from the environment. If it is emergency exposure situation, results from unexpected event requiring prompt response such as nuclear accidents or malicious acts. Medical use of radiation accounts for 98% of the population contribution from all artificial sources. and represents 20% of the total population exposure. In these slides, we can see the difference of ionizing and non-ionizing radiation and where we can see them. Non-ionizing radiation includes a spectrum of ultraviolet, visible light, infrared, microwave, radio frequency, and extremely low frequency, like in power line, radio, TV, microwave oven, satellite, and the cell phones that we have. Heat lamp laser too. For ionizing radiation takes a few forms: alpha, beta, neutron, gamma rays, and X-rays, like in tanning booths, medical X-rays, and radioactive sources. Let us now talk about the health effects of ionizing radiation. Radiation damage of tissue and organs depend on the dose of radiation received, or the absorbed dose, which is expressed in a unit called gray. The potential damage from the absorbed dose depends on the type of radiation and the sensitivity of different tissues and organs. The effective dose is used to measure ionizing radiation in terms of potential for causing harm, and we have this sievert, which is the unit of effective dose that takes into account the type of radiation and sensitivity of tissues and organs. The acute effects of exposure to ionizing radiation are nausea, vomiting, skin and deep tissue burns, impairment of the body's ability to fight infection, and this is what we call the acute radiation syndrome. This may happen when you are exposed to a high level of radiation, such as being close to an atomic blast. This may result within hours, days, or weeks, and the extent of the damage increases with dose. Let us remember that the dose threshold for acute radiation syndrome is about 1 sievert or 1000 millisievert. Chronic exposure can cause cancer, however, that may appear years or even decades later. Effects of this type will not always occur, but their likelihood is proportional to the radiation dose. The risk is higher for children and adolescents, as they are significantly more sensitive to radiation exposure than adults. Epidemiological studies on population exposed to radiation, such as atomic bomb survivors or radiotherapy patients, showed a significant increase of cancer risk at dose above 100 millisievert. More recently, some epidemiological studies in individuals exposed to medical exposure during childhood suggest that cancer risk may increase even at lower doses, between 50 to 100 millisievert. Prenatal exposure to ionizing radiation may include brain damage in fetuses following an acute dose exceeding 100 millisievert between weeks 8 to 15 of pregnancy, and 200 millisievert between weeks of 16 to 25 of pregnancy. Before week 8 and after week 25 of pregnancy, human studies have not shown radiation risk to fetal brain development. Epidemiological studies indicate that the cancer risk after fetal exposure to radiation is similar to the risk after exposure in early childhood. Limiting cancer risk from radiation in the environment. EPA, or the Environmental Protection Agencies, bases its regulatory limits and non-regulatory guidelines for public exposure to low-level ionizing radiation on the linear no-threshold model. The LNT model assumes that the risk of cancer due to a low-dose exposure is proportional to dose with no threshold. In other words, cutting the dose in half cuts the risk in half. The use of this model for radiation protection purposes has been repeatedly recommended by authoritative scientific advisory bodies, including the National Academy of Sciences and the National Council of Radiation Protection and Measurements (EXIT). There is evidence to support LMT from laboratory data and from studies of cancer in people exposed to radiation. Ordinance on Prevention of Ionizing Radiation Hazard, Ionizing Radiation Protection Act. Here are the links if you want to read and know more about it. To summarize on ionizing radiation, here are the key facts. Ionizing radiation is a type of energy released by atoms in the form of electromagnetic waves or particles. People are exposed to natural sources of ionizing radiation, such as in soil, water, and vegetations, as well as human-made sources such as X-rays and medical devices. Ionizing radiation has many beneficial applications, including use in medicine, industry, agriculture, and research. As the use of ionizing radiation increases, so does the potential for health hazard if not properly used or contained. Acute health effects such as skin burns or acute radiation syndrome can occur when doses of radiation exceed certain levels. Low doses of ionizing radiation can increase the risk of longer-term effects such as cancer. To wrap up environmental exposure to chemicals and each individual response, let us always remember these three factors. Number one, exposure. We have the level and amount, frequency, route, fraction absorbed, and the duration of exposure. Number two, we have the dose. It must be within the threshold limit. And lastly, the individual characteristics including the genetic makeup, the age, the gender, the health status, and comorbidities. With this, thank you for listening and God bless everyone.